All right, welcome there, function folks. Big day today, 3.12, proving trig identities day 1. You started doing trig identities in grade 11, and remember, you only had you had two that you need to remember. Two identities. It was this one and this one. Right, that's it. And then you proved some stuff using those two. Maybe the reciprocal identities were in there, right? These ones were maybe in there. Sorry, I had to pause there. I thought I heard a prowler, but it wasn't. It was the dog. Anyway, today we're proving identities, and so you can only imagine how grown up our identities are going to be with all the ones that we know. And so today's 3-minute review is, another chance for you to see if you can recollect them. And if you have a sheet that has all of them on it, that's handy. For the most part, try not to look. See if you can guess, and then look back and forth. Challenge yourself to remember them. Okay. The idea is you've got to get through this test coming up, and then on the exam you'll be able to write them on your formula sheet for the exam. But for this test, yeah, you got to get through and you got to remember. So this one's the sine of one and the cos of the other, and the sine of the other and the cos of the one. And these are angles alpha and beta. And so this is one of the ones that you really got to remember, because often we can develop the other ones from this one. This is a cofunction identity from a few days ago, cofunction identity, and this is the one we always think of. The cofunction identities have got the pi over 2, and it's always, the other, and that's why I knew I goofed it up. I was going to write cos there. It's the other trig ratio of the acute angle that's added on, and the only one that changes sign is the cos plus. Cos plus, that's a minus, so dandy. Tan of 2 alpha, geez, I can't even remember this one, but I do remember this one. I know that I have to remember the a plus b ones. This is this one. 1 minus tan of a, tan of b. But then I let b equal a, and then what do I get? Well, I got tan a plus tan a is 2 tan a on the top, and on the bottom, if b is equal to a, I've got 1 minus tan a squared. Do I memorize? I haven't memorized this one in all of my math years. I memorized this one somewhere along the line, and then I can develop this one quickly. Cos of minus theta, this is this even odd one, this is a cos of theta. And so the idea here is, when we go into proving stuff today and tomorrow and the next couple of days, that this stuff has to be bouncing around the back of our brain. Because when we see something that looks like a right side or a left side of one of these identities, if we don't remember them, then we're going to get stuck on these identities. Of course, as you're doing your homework, if you have that sheet there, it will serve to make things go faster, but don't lean on it too much. I'll have that warning. Okay, so how we're going to start with identities is talking about a puzzle. And really, that's what proving trig identities are. They're puzzles where we know that there has to be an answer. We know the left side must be equal to the right side. And so the idea here, you try this. Pause the video, see if you can get these. The idea here, we know that this must be able to change into this, and I'm just changing one little piece at a time. One little piece, and it's still got to stay English. We can't, there's no, if I change the C to a V straight off, vote, that's not how you spell vote, V-O-A-T. That's just not how you spell it. But if I change one letter and it's still an English word, and I know I'm on the right track, and I know that I've got to get to the right. So you try these puzzles, and this is the feeling of what trig identities are supposed to be. Pause the video, give them a go. All right, how'd you make out? Wasn't that fun? Well, this is the idea of a trig identity. We know what one thing has to turn into. And the idea is one step at a time, changing one little piece, and it's still being true math stuff. And let's see this in action. The next example, proving a trig identity. Your goal is to show that the two sides of the equation are equal, just like we wanted to show that one word can be changed into the other word one bit at a time. So you may do this only by substituting valid identities and working with each side of the equation separately. So this is like we do some math stuff, and we'll talk about what type of math stuff we might want to try here. And there are easy ones and there are hard ones, but the idea is I start with the left side and I have the right side, and I'm looking for turning the left side into the right side. So the right side of the equation is sine x squared, sine squared x, and the left side is this bracket business. And just like in the word questions, there might be different solutions. Like you might have not had the same solutions as me. There might be different techniques to proving this, but I know because I'm asked to prove it that somehow this can turn into this. And it doesn't matter the order. I can go back and forth. I can do one step at a time. One thing that I might be tempted to do here right away, because I see the brackets there, is I might be tempted to multiply that out, multiply the brackets out, right? Multiply everything by everything here. I might be tempted to do that. So 1 times 1 is 1. 1 times negative cos is negative cos x. Cos x times 1 is cos x. That's ugly, but that's still cos x. And then cos times negative cos is negative cos squared x. And then what's going on here? See, I'm always looking back and forth from left side to right side to see what's going on. This cancels, right? Bang, bang, gone. 1 minus cos squared x. And now I see a squared there and I see a squared there. This has got to be pretty close. It must be pretty close. And this is the idea of substituting valid identities. Well, one of the identities I know from last year is the Pythagorean identity, right? This is true. And I can use this to make a substitution. So for instance, I have this right here, right? That's that. What's it equal to? Well, I kind of got to rearrange this one. And I can think of doing this either in my head or in the margin, because it's not part of my proof. I move that to the other side. That's 1 minus cos squared x, right? So sine x squared, I'm going to make a substitution with this thing that it's equal to from an identity I've proven earlier, and I get cos squared x. And so now I have the left side equals to the right side, and the identity holds. And the identity is proven. Okay, now that one wasn't so bad. It was pretty easy, actually. This one just based on grade 11 stuff, and really all we needed to do was expand, right? The way I think of trig identities is, I know that there's a left, let me change color here. You don't have to copy this down. This is a bit of a story. The left side and the right side, right? And I know that they have to be equal. And generally, for the most part, there's a pretty clear path from one to the other. And I can work with both sides or whatever. And I almost think of it as a well-worn highway. From the left side to the right side that we go back and forth. We can go back and forth. It's kind of like this is the normal way to do it. Unfortunately, at times, what happens is we get off of the highway and we go someplace and we get into like a dark place where it's kind of scary and the left side's not looking like the right side. We're off into like a dark and scary forest. We're off the highway. What do we do then? So we're working with the left side and the right side, and they're not looking like the same at all. We've lost the highway. Well, what do? You stop and you go backwards, right? You don't keep going. You stop and you go back to the highway, which would mean crossing some stuff out and trying something different. Now, I want to show you something about the dark path. Okay, this isn't a trig a formula, and you're not writing this down. This is just a bit of a story. So somebody has started with this, the C equals A plus B plus D, and they're trying to prove this formula or develop this formula, and it's obviously some university stuff. It's hard. That's kind of hard to read, but they've made a substitution, and it's, you know, it's starting. There's a log in there, whatever that means, and some exponents, and then things are starting to get a little bit uh, worrisome. And in fact, this person should have been thinking, I wonder if I'm on the dark path. Well, I certainly feel like I'm getting off the highway. And then it gets a little worse. And then it gets a little worse. And now this person should be thinking, uh-oh, something bad's happening. But instead of stopping and going back, they soldier on, and I have fractions over fractions, and now it's starting to get a scared feeling. But this person soldiers on, and you can see some blotches on the paper there, and they should have stopped the truck a long time ago, right? Because look what happens. Oh no, dark path. Oh no, dark path. And this is how this person finished this development. So don't do this. At some point, you stop and you go back. Don't go to the dark place. I'm going to pick up with the rest of the note in part 2 and encourage you, and we'll sort of go over some strategies about how to stay on the highway and stay out of the dark path.